Hello friends, in last lecture we have studied series of non-negative terms. In this lecture we will take examples from exercise 3.2. So in that our first example is, if summation of n is convergent series of positive numbers, if summation of n is series of positive numbers, and ni is subsequence of n, then summation of n I equal to 1 to infinity is convergent series. Solution: given summation of n equal to 1 to infinity is convergent series of real numbers. So suppose summation of n equal to 1 to infinity equal to a 1. By hypothesis, n's are greater than 0 for all n. Now ni is subsequence of n, n's are greater than 0. Let Sn is equal to a1 plus a2 plus a3 plus dot dot up to an for every n. Then limit of Sn is a by 1, because this is the sequence of partial sums of this series. Okay. Now claim for subsequence ni of n series, summation of ni is convergent. Okay. So let Tk is equal to an1 plus an2 plus dot dot up to ank for every k. Then 0 less than Tk is less than equal to Snk for every k. Since n's are greater than 0 for all n, and ni is subsequence of n, which implies 0 less equal limit k tends to infinity of tk less equal limit k tends to infinity of snk and which is equal to limit of Sn is equal to say A. Okay. Moreover, implies Tk implies Tk is bounded above sequence such that Tk plus 1 is equal to Tk plus An, this is Nk, k plus 1, An k plus 1 is greater than Tk for every k, since An greater than 0 for all n. Okay. That is for this implies Tk is increasing bounded above sequence, and hence convergent, Therefore, summation of A n k equal to 1 to infinity is convergent series. As its sequence of partial sums Tk is convergent. Okay. So this is a simple proof of given example. Next example. Prove that 1 plus 1 upon 2 factorial plus 1 upon 4 factorial plus 1 upon 6 factorial plus dot etc. converges. Solution. For series 1 plus 1 upon 2 factorial plus 1 upon 4 factorial plus so on is equal to summation of 1 upon 2n factorial n equal to 0 to infinity. An is equal to, if I denote this by summation an is equal to 1 upon 2n factorial is greater than 0 for every n greater equal 0. Sn is equal to 1 plus 1 upon 2 factorial plus 1 upon 4 factorial plus dot etc. up to 1 upon 2n factorial for every n is such that Sn plus 1 is greater than Sn for all n. Okay. So Sn is increasing sequence. Implies this is your Sn plus 1 upon 2n plus 2 factorial. Sn is increasing sequence of positive numbers 1. Now if we show that it is bounded above, then we are through. Now Sn is equal to 1 plus 1 upon 2 factorial plus 1 upon 4 factorial plus dot x up to 1 upon 2n factorial. This is less equal 1 plus 1 upon 2. This is 4 factorial. Is nothing but 1 into 2 into 3 into 4. This is greater than 2 cube. Implies 1 upon 2 cube is less than 1 upon 4 factorial. Is it right? So, this is 1 upon 2 cube plus 1 upon 2 raised to 5 plus dot etc. up to 1 upon 2 raised to. See here, 6 factorial is nothing but 1 into 2 into 3, 4, 5, 6 is greater than 2 into 2 into 2 into 2 raised to 5. Implies 1 upon 2 raised to 5 is less than 1 upon 6 factorial. Is it clear? Oh, sorry. Ah, 1 upon 4 factorial is less than 1 upon 2 cube, and this greater than 2 raised to 5 means 1 upon 2 raised to 5 is less than 1 upon 6 factorial. So, thus we will get this to be 2n minus 1. Okay. And what is the sum of these are n terms? So this is equal to 1 into 1 minus half raised to 2 square raised to n upon 1 minus 1 upon 2 square. What is the ratio? First term is 1 plus 1 upon 2 factorial. So which is equal to 1 plus 1 half. If I take 1 half outside, equal to half, then 1 plus 1 upon 2 is taken outside, so we will get 2 square plus 1 upon 2 raised to 4 and plus so on plus 1 upon 2 raised to 2n minus 2. Right. So, which is equal to 1 plus half times 1 minus 1 upon 2 square raised to n upon 1 minus 1 upon 2 square. Since 1 plus x square plus dot up to plus x raised to n minus 1 is equal to 1 minus x raised to n upon 1 minus x. By using this, we will get this one. So, which is nothing but 1 plus half into 1 minus 1 upon 2 raised to 2n upon 1 minus 1 upon 4, that is 4 minus 1, 3 by 4, okay, which is equal to 1 plus 1 half into 4 by 3 into 1 minus 1 upon 2 raised to 2n. And therefore, limit n tends to infinity of Sn and this is less than 1 plus 4 upon 6, okay, 2 2s, 2 by 3. So, it is nothing but 5 by 3 into 1 minus 0, since 1 upon 2 raised to 2n tends to 0 as n tends to infinity. As n tending to infinity. Okay. Implies is Sn is bounded above by 5 by 3. From 1 and 2, Sn is convergent. Sequence. And therefore, summation of 1 upon 2n factorial n equal to 0 to infinity is convergent series. Okay. Next example. If 0 less equal a n less equal n, for n greater equal 0 and 0 less equal x less than 1, then summation of n into x raised to n, n equal to 0 to infinity, converges and summation of n into x raised to n equal to 0 to infinity is less equal 1 upon 1 minus x. Solution. So, for series, summation of n into x raised to n equal to 0 to infinity, 0 less equal n less equal 1, 0 less equal x less than 1 implies is n into x raised to n are greater equal 0 for all n. Let Sn is equal to and n into x raised to n is less equal x raised to n for every n. Let Sn is equal to a naught into plus a1x plus a2x square plus dot dot etc. up to an minus 1 into x raised to n minus 1, sum of first n terms of series Sn. Or if I take n greater equal 0, if I take like this, then 0 less equal Sn less equal 1 plus x square plus dot dot etc. up to, or if I take here x minus 1 n minus 1, okay. What does it matter? X raised to n, and this is equal to 1 minus x raised to n upon 1 minus x is less equal 1 upon 1 minus x for all n. implies Sn is bounded above sequence of partial sums of series of non-negative terms, that is of summation n into x raised to n. And therefore, Sn is convergent. Sn is convergent, and therefore summation of n into x raised to n is convergent series. Moreover, summation n into x raised to n is equal to limit n tends to infinity of Sn is less equal 1 upon 1 minus x from star. We'll get this. Is it clear? So thus result is proved. Result is proved. Okay. So with this discussion, we'll stop our 6th lecture on series of real numbers here. Thanks for listening lecture carefully. Bye bye.